Welcome to the second tutorial video for the Johns Hopkins Final Project Walkthrough. In this video, I'm going to cover the project-related steps that will take place before and during needs analysis. I'll also go over the system that I'll be walking you through for these tutorial videos. So the first thing you need to do once you're given access to the EN 645-800 site, which looks like this, is to access and read the entire Systems Engineering Project Guidelines. This will give you an overview of the scope for the project, expectations, and an outline for the project deliverables. One of the key areas of focus in the project guidelines is the grading rubric. If you focus and apply your attention to the grading rubric, you'll set yourself up for success throughout your project. Something to consider while reading through the project guidelines is to create a bulleted list of the concept paper requirements, so you could check the box, so to speak, next to each requirement to ensure you include each element in your concept paper. I would recommend reviewing the project guidelines for each particular deliverable as you're developing the deliverable and use the same technique or your own. I should mention at this point, the way it works with submitting the deliverables is that the concept paper is first submitted to your mentor on Blackboard, and once they approve by giving you a 1, you will then submit the approved deliverable to the instructor. I'm going to show you how to access that real quick on the 800 site. Go down here to Project Deliverables, click on that. And down here you've got instructor deliverables and mentor deliverables. If you click on mentor deliverables, it opens up dialogues for you to click for each deliverable for you to submit to your mentor. Now here's a list of all of the deliverables that your mentor will be approving, and here's a list of the deliverables that your instructor will be approving as well. So there are only 3 for the instructor, and there are several more for the mentor. It's okay to submit draft copies of your deliverables on Blackboard, as there are unlimited amounts of attempts, and subsequent attempts don't count towards the approval for your approved deliverable. It's my own preference to receive deliverables on Blackboard instead of through emails, as this centralizes all of my student submissions into one area. Talk to your mentor about what their preferred delivery method is. Another thing I recommend is to go into the Project Examples area on the 800 site and get a general idea of what other students did for their concept papers and their other deliverables. And that's found right here under Project Samples. And for me, if you're going to use core, I recommend going to core-based projects, and you could choose from this list right here. So we'll pick this one. And here is this student's deliverables for his project. So you can look through these and use them as templates if you want to, or to get a general idea of what's required for each deliverable. Another recommendation of mine is to attend Steve Beamer's online office hours every week as you develop your project. They're a very good resource that will provide guidance, insight, expectations, and rules of thumb throughout the development of your project. The content of these tutorial videos that I'm doing will not serve as a replacement for Steve Beamer's office hours, so please refer to those also. As of the making of this video, the online office hours takes place on Wednesdays at 8 p.m. Eastern Standard Time. Steve also records his office hours, so if you can't make it to the Wednesday meetings, or if they're overcome by events as you're watching this video, then go into his forums and watch the recorded video for his office hours. I'll show you the path right now. If you go down here to Groups, scroll down to Steve Beamer, Mentor Steve Beamer, scroll down to the bottom, click on Group Discussion Board, and here's the discussion board as it stands in 2014, and down here he's got his Fall Office Hours 2014, and here's a list of all the office hours. I'll click on the first one for an example, and then here's a link to both the PowerPoint presentation and to the recorded online office hours. So now you're watching a pre-recorded session of Steve Beamer presenting his online office hours. This particular one, the very first one, has to do with the concept paper and the proposal and some frequently asked questions. I should caveat that in conjunction with watching these videos, work with your local mentor for your project-specific questions or submissions. So once you have your list, or however else you're tracking the requirements for the concept paper, I highly recommend reading Chapter 6 in the Systems Engineering Principle and Practice textbook thoroughly. Highlight important passages you'll refer to again in the future, and take notes for topics as they relate to your project specifically. In addition to Chapter 6 in SE&P, read Chapter 6 in the Dennis Beatty book and various relevant chapters in the Charles Wasson book. These chapters should be retained in order for you to truly begin to master the subject. The chapters that come to mind to help you specifically for your concept paper in the Charles Wasson textbook are chapters 10, 11, 15, and 21. Wasson's chapters are rather short, so don't be discouraged from reviewing 4 or 5 chapters at a time. I also recommend looking through it and remembering where you may be able to find good information for later on. If you skip reading the textbook and continue pressing with your project, relying solely on these videos or your mentor to assist you, you will fall short of your depth of knowledge for systems engineering, and it will ultimately have the greatest negative impact for you when you brief your final project. So please don't gloss over or skip learning these critical skills. Remember, this is a master's in systems engineering. By implication, you must have this subject matter mastered. A good source to have on the side for quick reference during needs analysis will be Introduction to Systems Engineering Lecture 3.1, which discusses needs and requirements, and the Conceptual Development Lecture 1.3, which discusses problem definition. If you want to take it a step further, watch the videos for these lectures again just to let it soak in. They are in Modules 3 and 1 respectively for these courses. If you do not have access to these courses through Blackboard, get in touch with your instructor so they can grant you access. I'm going to show you how to access those right now. So you'll go over here to where your courses were. I'm going to go to the Introduction to Systems Engineering. Over here in Course Modules, click on that. Module 3, which is Requirements. Here are your lectures. Click on that. Lecture 3.1, there's the PDF copy, and if you click on this link here on the top, that opens up a video for you to watch of the lecture. Going back, I'm going to go to System Concept Design. Same thing, Course Modules. Module 1. Scroll down to Lectures. 1.3, Problem Definition, PDF. And I don't believe this one was recorded for this particular example. The online version does have it recorded if you have access to the online course. As you're reviewing the chapters and slides, write down any ideas that pertain to your project specifically. If you're taking notes electronically, try using tags for quick reference. This may seem like a lot of upfront work, but as with the system's lifecycle, the more time you use in the front to gain a thorough understanding of the project in systems engineering, the greater the dividends will be on the back end, to include the application of systems engineering in your real-world jobs. So once you've reviewed the materials and made notes, formally enter your own needs analysis phase. To keep it simple, refer to Chapter 6 in the Systems Engineering Principles and Practice textbook, and specifically to the diagram on page 147. I should mention that even though the concept paper and proposal guidelines did not request a list of operational objectives or a set of subsystem functions, you should still perform operations analysis and functional analysis and enter your data into core, as these need to get you to the feasible system concept, which you do need in your concept paper. I will get to that when I perform needs analysis on my own project in the next video. Needs analysis also assists you in developing your system context diagram as you identify and describe the higher-level interfacing elements. This is a very useful diagram both to help you stay focused on your areas of influence and to identify those areas you cannot influence that your system must take into account or adapt to. It's also useful for obtaining stakeholder buy-in for your project, the stakeholder in this case being both your mentor and the instructor at Johns Hopkins University. As I previously mentioned, as you're developing your concept paper, input your top-level needs, your operational objectives, your subsystem functions, and your top-level feasible system concept definition into the core database and make the appropriate relationship connections. I'll show you how to do this in a following video. At this point, your project will contain very little information in the core database, and that's fine. Remember, we're performing top-down systems engineering. Systems begin at a high level and are refined with each iteration of the systems engineering process. So you're only going to have a few requirements, a few functions, and 1, possibly 2 components in your core database. It all truly depends on your particular project. One of the last items of work for you is to develop your project schedule. As outlined in the project guidelines, you can use a tool such as Microsoft Project, or you can keep it simple and use either Microsoft Word or Excel. My best advice for you when you develop your project schedule is to download a complete final presentation slide package from another student and look at their actual hours from their projected hours and use this, their actual hours, as a baseline for your project. You can look at several different students' actual hours and kind of average things out if you wish. Something a lot of students haven't done in the past, and you should begin doing, is to include mentor review times, instructor review times, time taken to read the material I've talked about, watch the videos, and teach yourself how to use core. This will give you a more accurate and realistic schedule that you won't be pressing, and you'll reduce risk significantly. After that, it's all a matter of organizing and drafting the concept paper for submission to your mentor. One last thing before we get into the project, let me show you how to download and install core. So the first thing you're going to do on the 800 website is go in here to Tools on the left-hand side, click that, go into the core link right here. So there's the University Installation Guide, which is okay. I think this video is probably going to show you a lot faster and easier how to do it. So click on this core link right here. And here's this page right here. This is fuzzed out, but copy this password to your clipboard and remember your instructor. It's either going to say Christian Utera or Beamer, Steve. Remember those. And then we're going to click this Vitech website link right here, take us to a different page. Now, the Vitech website is, in my personal opinion, not very user-friendly when it comes to downloading and installing core, so just watch what I do and follow along. So what I'm going to do is scroll all the way down here at the bottom, click on Software Downloads, and then down here under Products, we're going to look at, all the way at the bottom of the list is Core 9 University Edition, 75 megabytes. So click on this link right here, actually right click and save target as, you can do that. I'm going to save it to my desktop. And once it's downloaded, I'm going to go ahead and click on Run right here. Click on Next. I accept terms. Username, you can say, I'm going to say Olson-JHU on there. Organization, Johns Hopkins. Anyone who uses this computer, for me. I'm going to go ahead and leave this on the default. Hit Next. I'm going to do the complete installation. Hit Next. This is for when you generate reports out of core, so we're going to follow the US letter standard. And then we're going to install it. And then once it's finished, go ahead and click Finish. And then let's hit the Start menu and go to Core 9 University. And now it's searching for a license. It's going to come up with this dialog. So once you're in this dialog, go ahead and copy this. Click on Request Key right here after you've copied it, and it'll take you to a different web page. I'm going to go ahead and get rid of this splash screen over here. We're going to fill this information out right here. Once you get to this point, go down to the instructor right here and go down to Johns Hopkins University. I'm going to select Christian Utera. And then this it looks like it auto-filled license. So what we have to do is go back to the Johns Hopkins 800 page, which is right here, and copy this. And then go back here and paste the password in. So this password is going to change every semester or every 6 months or so. So this is only valid obviously until 30 June 2015, and you might be watching this video past that date, in which case follow the link on the 800 website and there will be a new one there. And then we're going to request the activation key. I'm going to select no here because I'm already subscribed. So request activation key. So now what we have to do is we have to check our email that we provided for them, and I'm going to do that right now. So now that I'm in my email application, the Vitech sent me this email, and in here we've got the license, we've already got that, but now we've got the activation key. So I'm going to go ahead and copy that, and then up here in our Core 9 splash screen, I'm going to go ahead and paste that in there, and then apply key. Here we've got 212 days activation on this. And there's their phone number if you need it. They'll have it on their website as well. So I'm going to click OK, and we should be good to go. So here's what Core looks like. So let me quickly run through some of the interfaces in Core and get this thing set up for you. First things first, let's go up here to Model Assistant in the upper left-hand corner inside the project pane. And You could read through these and decide which ones you like and which ones you don't like. The one that I would definitely recommend unchecking is this one right here, the auto create root functions. Uncheck that, because essentially what that does is once you get to physical allocation and you start creating components in your database, Core automatically creates functions that are performed by that component that you just created. And that's, in my mind, more useful for bottoms-up systems engineering instead of what we're doing, which is top-down systems engineering. So we start with the function and allocate to physical components from there instead of starting at components and then having Core create some functions for us to kind of give us a placeholder. So we're not going to be doing it that way, and that will prevent some heartache later on when you do physical allocation. So let's talk about some of the interfaces here. Up here on the title bar, at the top, we've got the typical Windows type of titles. We've got the file structure, self-explanatory, import and export. And this is how you'll save your Core files. You'll do export Core University data file when you save it. Edit menu. It's typical edit menu here. The view dialog. So this is a different way of viewing certain things. You can uncheck these and it'll remove them. Another way of doing that is up here on the toolbar. Table view. So these are all self-explanatory. Project tab. This open a new project, close a project, erase data, and manage and so on. I really didn't use this very much, but one thing that is on the project is the project preferences, which you'll find some of the more detailed ways to include or exclude certain diagrams and things that you want to include or exclude from your architecture or from your database. The data itself, this is also self-explanatory. New piece of data, delete data. You can manage it different various ways. I have to have something selected for most of these things to be highlighted. And we'll just, when we do the project, I will be showing you some of these features as we do the project. And you can always explore on your own as well. Got filters going on here. We really don't use those very much in the project. And then some target attributes going on here. Schema, I would not recommend breaking into the schema for this. In fact, you're quite limited with the University Edition, but basically the schema allows you to change relationships and what their associations are within the Core database. I would keep it the way it is right now for your project. Utilities, we've got different utilities right here. I didn't use this feature when I did my project. The different types of diagramming, these are grayed out here because I don't have anything selected in my database, but when I do have something in my database, these two become highlighted and I can use them. Tools is right here, so we can look at the Explorer for different projects. You can create the document. This is for your requirements analysis report and your functional analysis report and so on. This is how we're going to do that. Run script editor for that. Your user preferences are right here, so the different things that you like or don't like about Core, you can go in here and customize anything you'd like. So you can just go through here and kind of poke around and see what you do and don't like. Just remember that when you do edit diagrams and things like that, typically it takes hold only on that one specific diagram. So for general overall diagram changes, go into the user preferences right here into the overall diagram. For example, functional flow block diagrams, you can change those things right there. IDF0 diagrams and so on and so forth, n-squareds. And then we've got the help file here. And inside the help file, some really useful things in here are the guided tour, icon reference guide, model-based systems engineering primer, which didn't used to be free, but now it's available for free, and I would highly recommend that as a fourth source if you truly want to dive deep into it. The system definition guide is a really good resource. The system definition guide is a pretty useful tool to find out what the different relationships are between the elements in Core. Core Sim user guide, script construct guides, really not useful for your project. It's useful, but not for your particular project for Johns Hopkins. Tips of the day, help contents, customer support. They've got a really good, Vitech has a really good customer support team set up, and they will typically have a shorter than 24-hour turnaround time for any questions that you have that these videos don't particularly answer. Online community for systems engineering, submit feedback for Vitech if you want to give them feedback for how this tool could be more useful, and you can check for updates here. So let's break into what we're looking at. Up here at the top, we've got a toolbar. And let me just put an element in here just so we can highlight what all of them are. So I'm just going to create a function real quick. That way all of these things start appearing. So over here we've got the database view. And this is a way for you to export your project. That's basically the same way as going up here to the file and export, but this is just a shortcut for that. Right here we've got print. Print is self-explanatory. Right here we've got export data in Word format. So this is useful when you want to export particular elements or entire database files or what have you for your project. I didn't use this when I did my project. You're more than welcome to try and use this. What I did instead was run a script, and that's this next one right here, and I'll break more into detail about that later on. Instead of taking up a lot of time talking about how this works, let's do it when we get to it. Document parser. So if you have requirements that you wrote down in Microsoft Word or Excel or what have you, you can import them through the document parser right here into Core. Just takes a little bit of time to get them all in there. Here we've got a time-phased simulator for when you do functional analysis. As an option, you could run a time-phase simulator to see if you're meeting particular requirements or not, in particular time-phase requirements. This is a different way of viewing the core data. I would keep this on full detail. You don't really need to use any of the other ones. These four boxes up here basically are your view boxes, and this one on the far left hides the project pane, which is this left side column right here. This middle one right here hides and shows the elements pane, which is this middle one right here. And this far right one hides and shows your individual elements dialog pane, which is the big area that you'll be using most of the time on this project. And then we've got the table view right here, which shows basically your traceability. And you'll be exporting your traceability with this table view right here. So once you're in table view, to get back, just click on this one right here, and it'll bring you back. Here we've got hide updates from other windows and users not used for your Hopkins project. Here we've got folders that you can create if you want to organize your different elements inside of folders to keep things kind of neat and tidy for you. You can use folders and subfolders and tiers and so on. When I did my project, and when I'm going to walk you through it, I'm not going to use folders because I think the numbering system and the hierarchy structure that I'll set up basically does that job for me. Right here we've got create a new element. So we are currently in function. So if I click on this create a new element, it's going to create a new function right here, and you can name it what you want. So I'll just name it like that, keep it the default. And now that we've got one function highlighted, these other buttons become active. This one will be useful later on when we do the numbering system, and I'll show you how to do that when we get to it. Perform completeness, consistency, and custom checks for selected elements, so you can look at different traceability for different elements here. Set permissions. This is not used for your final project. Delete elements. This is basically the same as hitting your delete key. Open the property sheet. So this shows you basically what you're looking at here, but broken out in its own window. So if you want to break things out and look at your traceability table, for example, and your elements at the same time, you can do that. So you can add things and modify things, change relationships, and so on and so forth as you're in the, that's just one example. So going back here. So here's a way to view a spider diagram for this particular element for function 002. You can look at a hierarchy diagram for function 002 here. These elements here only become active when you have components selected because these have a relationship directly with the components in here. So let's go over here and create a new component. And now these are highlighted and active. So right here we've got a state transition diagram, and we can talk a little bit more about that when I go over modes, phases, modes, and states with you, at least according to Charles Wasson. We've got structure block definition diagram here. We've got just basically different ways of viewing the physical architecture once we get to that point. Interface n-squared diagram, interface block diagram, all these different ways of viewing interfaces, your internal block diagram, physical n-squareds, physical block diagram, open a flow internal block diagram, all kinds of different ways to see your physical architecture. So let's go back to functions here. And these other elements are still active for functions in particular. Enhance functional flow block diagram. This differs from functional flow block diagram in that it shows your inputs and outputs on the same diagram, whereas the regular functional flow block diagram does not include your inputs and outputs. Activity diagram, self-explanatory. Sequence diagram, same thing. Open and end squared diagram right here. And you learned a lot about those in your systems engineering courses. Here's an IDEF0 diagram. Here's an IDEF0A0 context diagram. And then we've got this drop-down dialog box right here where we can go in here and edit the toolbar and include or exclude things that we do or don't necessarily use throughout our project. And as you're using yours, you can go ahead and customize how you'd like things to be included or excluded on here. So I'm going to go ahead and hit cancel for now. Now let's talk a little bit about the project pane right here. We've got the home page. Another one is the model assistant, and we already went in here and changed some of that stuff. So go through and read these, and as you're doing your project, you may or may not need some of these different things. Properties right here, so this is just essentially the properties view for your entire project. Now here's where we get into the database. Packages, we're not going to use those. Facilities is different ways of viewing elements in the core database, and the one that we're going to use is the systems engineering facility because that shows all of the elements that we're going to use throughout our project. And here's a list of all of the elements in the database that we can use. So I'm just going to touch on the highlights. So component you'll use during physical allocation. You can raise concerns, and the reason why Vitek included concerns and risks in here is if requirements or solutions, physical solutions and so on, are driven by something other than requirements, for instance, or they drive requirements, then this provides complete traceability. Let's say you've got a concern, and that concern opens up basically a new requirement. Then you could see the complete traceability back to that concern, and if the concern becomes OBE, then that requirement becomes invalid. So we can avoid things like scratching our heads wondering where particular requirements have come from. Defined term, this is self-explanatory. Documents, also self-explanatory. Domain set, that's advanced, and we probably won't use that in this project. Event, same thing. Exit, this is for our functional flow logic. External file is for referencing an external file, such as when we create a requirement in the database and it references to like an industry standard or something, then we can import that external file into the database, and that way when we want to reference that, we can use that external file linkage. Function, we've already been here 2 times, so we've already got 2 functions in here, and that's self-explanatory. Interfaces, so there's an interesting thing about interfaces and links in core. So the way Vitek set up interfaces is they are pretty much independent of links, and I would highly recommend when you do physical allocation to choose either interfaces or links and not both. So the thinking behind the folks at Vitek when they created interfaces and links is that interfaces were in reference to something external to the architecture or what you're developing. And links are basically those things, those physical connections between 2 components that exist internal to your boundaries, your system boundaries. The reason why I don't like that is because when you have a system of systems or even a system level and you're working on a subsystem, at the system level, your system boundaries change from the subsystem level. So if you're working on a database at the subsystem level and it rolls up to a system level, the subsystem interfaces are now system level links if you use that definition. So that's why I recommend using links. And folks at Vitek, if I'm speaking incorrectly about those, please let me know and I'll go back and correct the video. But based on what the manual says, that's how those were developed in core. Items. So the items are your functional interfaces. This is where your inputs and outputs are in relation to your functions. And when you link your functions together, you want to use items to do that. And you can see that right here in the input to and the output from relationship. Link, like I talked about a little bit before, this is your identification of your physical interfaces between components. So this attaches only 2 components together. It cannot attach 3 or 1 and 0, for instance. It's 1 and 1 exactly. 1 on one end and 1 on the other end. Modes, we'll get into that when we talk about phases, states, and modes. Package, I didn't use this at all when I did my project. Requirement, self-explanatory there. This is probably one of the biggest elements you'll use, especially in the beginning. Resource, if you want to do resource allocation, you can do that here. Risk, this is much like the concern. So if you have a risk that drives requirements or risks that drive functions or physical solutions, then you can document those here and provide that linkage. You can do both documenting the risk in your risk management report as well as creating the risk in the database here just so you have that linkage. Service specification, this is not used for your project. So states, these automatically are created when you create components. So when you create a component, it automatically creates a state. So we can disconnect that by going into here and unselecting auto create root states right here. So then it won't do that anymore. Let's test it out and see. So now we're still at 3. So I'm going to go in here and just delete these components by using this from the database. Sorry, not components, they're states. Text, not sure exactly how that's used. I didn't use it. Transitions, so this is when you're doing your functional architecting. So this is used along the same lines as the events and so on. Use cases, so if you do use cases, which I highly recommend you doing at least for your primary mission scenarios, here's where you can document those and make the appropriate linkage to requirements and functions and so on. And then verification requirement. Interesting thing about the verification requirement in core is since you are not required to develop verification requirements for your final project, this area will remain unpopulated. One of the things I would like to see on the Vitex side is if there was a drop-down in the requirement element that showed the verification method. So if we could show the verification method somewhere in the requirement, then that would be a good alternative to actually having, instead of actually having to go back and write a verification requirement for that. And they even have a dedicated verification section for that. We're not going to use that. We're going to stick to systems engineering for this. Back down here, related projects, we're not going to use that. Here's another link to the schema. We're not going to use that. And then we've got utilities here. You could play around in there if you want to, but I highly recommend not doing that because you might mess your architecture up. So we're going to stick, for the most part, 99.9% of the time in the project is going to be spent in here, touching these elements in here. So let's talk about the next pane, which is the elements pane. And when you have a element selected over here, like I've got functions selected, this will have a complete list of all of the functions. Or if you have a folder in here, you're going to have the folder underneath function, and I'll do that real quick. You're going to have a folder underneath function, and you can fit the different functions into the different folders if you want to organize them that way. So just click and drag those, and that's something that's new to Core 9 is being able to click and drag, which is really great. And notice also that the total number of functions stays at 3. However, you'll have to go into every individual folder to find out which one goes where. This becomes a little confusing as you're doing your architecting, in my own opinion, because sometimes in order to accomplish tight binding and loose coupling, sometimes you need to reorganize a lot of your functions into like folders or like categories, in which case folders kind of cloud up the situation a little bit, especially if your different functions have relationships with both requirements and with each other through the items. So I'm going to go ahead and go in here and delete this folder. And when you delete a folder, it does not delete the functions inside. They just default back up to the higher level folder. So back to the elements pane. So here we've got a drop down, and here we can filter out different attributes for these elements if we've got hundreds of them. You probably won't be using this on your project, but if you wanted to, you could filter things out there. Going over here to the properties dialog box. So here's where your name goes, obviously, the number. Pick an intuitive numbering system for your project. For example, for all of your functions, you can choose f.1, for example, for your parent level function, and then all of your children will be f.1. whatever. Or you could do f.0 or so on and so forth. The description of the function would go in here if you have that. Document PUID is not used, and the title for that document is not used as well. And neither are these tabs right here, secondary parameters and diagnostics. If you want to go in here and play with these, you're more than welcome to, but you're going to stick to the main attributes tab for the most part. Now down at the bottom, we've got where we make all of our relationship connections. So this is where we connect all these different elements over here on the left-hand side to each other. So how each is based off of others and they're driving other things is made through the relationships down here. And you can see all the different kinds of relationships functions in particular can have with any of the other elements in the core database. Actually, to go through this list, let me just talk to you about what things you'll be using the most. Starting with requirements, let me create a requirement here to have something to talk about. So for your requirements, down here in relationships, so the ones you'll be using the most on your project related to requirements is basis of, so it forms the basis of functions and use cases and so on. Causes, if you have any requirements that cause risks. Generates, if your requirement generates a concern or a change request. I didn't use change request packages at all, but if you have a concern, you can generate a concern for that. So the most often used ones for your requirement is going to be refined by, which is right here. So that's pointing to lower level requirements, and then refines, which is lower level requirements pointing up to higher level requirements. And once the connection's made, if you go to the different element, it's going to show that relationship also at that level. And then result of will be based on if you have a risk that's driving a new requirement, then that requirement can be the result of the risk or the concern and so on. Specifies, if you've got a constraint requirement and the requirement is specifying a particular function or a component or an interface or an item or a link or what have you, you can make that connection here. Utilized by and verified by are not used for this. Going down to functions, the most often used will be allocated to, so that'll be allocated to components when you get to functional to physical allocation. Based on is another one, so if a function is based on a requirement, that's where you'll make that connection. Decompose by other functions, so that's pointing from high level to low level, and then decomposes, that relationship's established when you do that. This points from lower level to higher level. Exits by, if you're using exits for your functional flow logic. Inputs and outputs are used to link back to your items that connect your different functions. Result of, just like requirements. Specified by points back to your requirements. Triggered by, utilized by, verified by are not used. You could use triggered by and utilized by when you do your time-phased architecting if you wish. Going to components now, so these are the three primary elements. Components, the ones that you'll be using the most are built from and built in. So built from is pointing from, again, from high level to low level. And built in is pointing from low level, components up to subsystems and subsystems up to systems and so on. Causes, same relationship here with a risk. Here's where we can make a connection between modes. So if a component can contain different modes, or a component can exhibit states, a component can generate a concern. So the join to is where you make, if you choose to use interfaces, where you can make the connection between components and interfaces. If a component performs a particular function, this is where you have your function to component traceability. You'll be using this a lot. Specified by, if you've got a component that's being driven by a requirement, this is where it's specified by. Typically this is only for constraint requirements where a requirement is dictating that an actual component must exist in the architecture. So you shouldn't trace this back to all of your requirements. This should only be traced back to hard requirements that are driving that particular component. And supplied by and utilized by, not used in here. So I think that's it for the introductory look at core. We'll be diving a lot deeper into each one of these things as we walk through the project example. So stay tuned for that, and I'm going to go ahead and end this recording right now.